D2DNY, Real World HVAC Simplified. And now, in this video, I'm going to be showing you how to use this Megger meter, Megger ohm meter. Okay, how to use that to test the windings of your compressor. Okay, also I'm going to be explaining the reason for this test, what is exactly happening, or what's exactly happening when you do a Megger test, right? And the problems or symptoms associated with a compressor or motor winding, if in fact this motor winding or compressor winding, compressor motor winding rather, would fail or failed a Megger test or Meg test. If it fails, what's going to be some of the symptoms, so you can be proactive on your maintenances, because that's what I'm doing right here in this chiller. This here is a medical chiller. It supplies chill water to MRI scan machine. All right, but before we get into the video, I'm going to say this. If you have not subscribed, do so right now and smash that bell icon so that when I upload videos like these, you get them right away. All right, so first we're going to talk about what's really happening with your Meg meter. You know, this particular Megger meter or Megger home meter. Now this video also, I just want to say that this is for pros, beginners, not for do-it-yourselfers. Do-it-yourselfers, this is not for you. All right, pros and beginners. Pros, you can chime in, because I know that you're going to say that you have other ways of how you do it. You don't exactly do it this way or my way, but I'm going to show you the best way in this video. Okay, so this particular Megger meter, unlike your regular ohm meter, this one right here, unlike this one right here, right? The difference between the two, this one here has a ohm scale. There's continuity and just regular resistance reading, as you can see right here. It goes up to kilo ohms or k ohms. But this right here, this one here measures in the millions of ohms. 2000 megs this one goes up to. All right, that's very, very high. As opposed to kilo, this is millions. Kilo is 1,000. This is millions. This is meg, millions. All right, and how it does it is that you can see here on this particular one, I have 200 megs at 250 volts. I think it goes higher than 2 million. 200 million. 200 million. 2,000 million. Right? So that's a lot of resistance. So at 250 volts, literally this meter will put out, if I put it on this scale, when I hit the test, it's putting out 250 volts across these terminals right here. If I move it down to the 500 volt scale, when I hit test, this button right here, it's putting out 500 volts DC across these two prongs, your test leads. Okay, if I go down to 1,000 volts, that's exactly what it's putting out, almost like a taser. Now other Meg meters, they don't have, this is more fancy, right? The fancy meter. The other popular one is by Subco, and it's just a series of lights that shows you, you know, good, bad, or caution. And I think that one just puts out 1,000 constant or 500 volts constant. This one you can select whatever you want, and you can also go over here and do regular ohms as well, regular resistance reading. Okay, so let's get into the video right here. And again, once again, like I said, if you have not subscribed, do so right now and smash the bell icon. So let's get into the video. Okay, so I have my meter all hooked up and ready to go. My negative probe, my positive probe. All right, so all ready to go, ready for testing. All right, so what I have the negative or the black attached securely to the ground, chassis ground or any ground in the unit. You can go on your compressor discharge pipe or your suction pipe, any ground on the unit, because that's what you're testing. When you're Meg testing or your compressor winding and what you're doing, you're actually testing the resistance of the actual winding in the compressor between the grounding of the unit or the grounding or the casing of the compressor, right? So the case of the compressor is always going to be grounded to the chassis ground or the copper pipes. It's all metal, it's all connected. So inside you have the windings that makes up the compressor windings. What do you call that? The stator. If I'm not mistaken, you can probably correct me in the comment if you know. The stator. So the windings make up the stator. And so these windings, they're like they don't have plastic coating over it like these here, right? They have sort of like a paint, and over time sometimes these insulation over the copper wires instead of the compressor windings, they break down and they're touching to the chassis ground, and with that it draws a higher amperage, especially when the compressor gets hot. Right, so it's not really going to give you a regular, if you use a regular meter and you test between your compressor winding to ground like so. So you can hear in this meter is going, it's beeping. Because I got continued to the ground. Right, so with a regular meter, and this meter has the ability to do that because I have a regular home scale. Right, it's a Megger meter that has that function. But with a regular meter, you will get that the compressor is grounded if it's actually fully grounded. So there's a real bad short. But if it's just slightly touching, right, at times it might pull a high amps, it might trip your breaker, it might blow your fuses, and you don't know what's going on. You need to run a Meg meter. I mean, a Meg test, right? Because the compressor, when the winding is getting insulation and the compressor is getting weak, and it's slightly touching to ground, it's not fully grounded, it's not fully shorted where you can use a regular continuity test for it to ring out like so, right? At that point, with vibration, when the compressor works hard and it's really hot, it will trip your breakers, it will trip your overload, it will blow your fuse, and then you'll replace these things, put them back together. It will work for a while. A couple of weeks later, same problem. You gotta run a Meg test, you gotta check that windings, or check the wires that leave the contactor and goes to the compressor. You gotta check those, because sometimes these wires, based on vibration, they could rub amongst the chassis and create a slight short or current leak to ground, and that could trip your fuse and blow your breakers and stuff like that as well. So that's what's going on with the windings. Again, if you got questions regarding this, leave it in the comment, I'll answer. What else? So yeah, so that's pretty much that. Let's get into testing. So initially, what you're going to want to do is make sure the power is off to the device that you're testing, the motor windings or compressor motor windings that you're testing. Make sure the power is off. Now in this particular scenario, it's a medical chiller. I cannot shut down the power to the entire unit. However, that is recommended. As a pro, sometimes you're going to have to do work on the system while it's live. In order for the system to be completely down, an appointment has to be made, scheduling, etc. It's a lot involved. So I'm careful, I know what I'm doing. I can do it while it's live. So I'm going to go ahead and turn off the power to the actual compressor, which I'm going to be testing. And this right here, you can see the main power. This is the main power coming in the bottom here. It comes around top of the contactor. It's labeled line 1, line 2, line 3. Okay, so there you go. And so if I test right here now, I'll have voltage, but I'm gonna go ahead and turn this off. Boom. So I'm off. So now I can simply push the contactor. Nothing happened because it's dead. You know what? I'm gonna go ahead and test it dead. Okay, so you know I am on camera right now, so I want to show you guys the right way. So I went ahead, get my meter. You can see I have power on the top of my overloads. All right, that's 473 volts. So there's power up top. If I go to the bottom, right there, it's dead. If I go to my contactor, okay, it's dead. So I can work from here, where the power is supposed to come in. It leaves the overload, or down here in the bottom, comes around. So from here is dead, up here is hot. All right, dead, 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 hot. All right, so I can work. Again, always the best practice is to shut down the main power while you're working, but I've already explained why I can't do that right now. Yeah, so now that I have my power off, I'm gonna go ahead and test. I'm gonna move my meter. So the first thing that I'd like to do, or you should do, because I'm showing you the best way right here in this video. You're gonna want to do the regular ohm continuity test first. All right, regular ohm continuity test first. So you have one of your test lead and ground, because we're testing the motor windings resistance to ground. And so I'm gonna go. This is where the power comes in on top of the contactor. This is where it leaves and go to your motor or your compressor in the bottom. It leaves in the bottom. All right, that's where it leaves. T1, T2, T3. If it's wired up correctly, that's where it's leaving. Power leaving the contactor. So these are your 3 wires to your motor or compressor terminals. So I'm gonna go ahead. I'm on continuity, right? One of my leads to ground. I'm gonna take the other lead and I'm gonna go from each wire. So each wire. So that's good. Not shorted. Not shorted. Not shorted. All right. If it was shorted, I'll get something like this. Oh, my meter just turned off. Go back. All right. If it was shorted, I gotta find a good ground. Here you go. That's what I'll get. So I like to do this because I don't want to burn my meter out to send 1,000 volts into this thing, and it's already shorted, and I can use my regular ohm meter to detect the short. You know what I'm saying? I want to use this only when the short is so minute that I need to send 1,000 volts out into the windings to check that against the ground. If it's a bad short, a regular meter like this could do it. This meter right here, again, has this option. I could have used this one, put it on the regular home scale, and just, you know, do the same test from each winding to chassis ground. And this meter will work. And if it's a bad short, because a dead short, you know what I'm saying, it will ring out, give me continuity to ground. All right. All right. So that's that. So first part of the test is done. I'm gonna go ahead. I'm gonna go over, and I'm gonna go to 500 volts. All right. 500 volts output, and this meter here, I hit test, and then I press locked. Test plus locked. It holds it. So constantly it's putting out 530 volts. So now, what you don't want to do is touch here and touch there, the ground, simultaneously, because you'll be zapped. I'm gonna go ahead now and hit here. Look at my meter. That's good. The 1 on the screen means it's overload, infinity. It's higher than 200? Yeah, 200 megs. It's higher than 200 megs. Alright, so that's good. So I'm checking all 3 windings, all 3 terminals. Alright. So all 3 of them is good. Alright. So the first phase of the test, I'm gonna move back. Move that to 1000 volts. I'm gonna do the same thing. I'm gonna hit test and I'm gonna hit continuous. So that's 1030 volts coming out from this thing, between this thing and that thing right there. Right, these 2 prongs. Between black and red at 1000 volts. So let's go here. Now, so anything below 100 megs, that's caution. Anything below 50 megs, it's bad. So you can see we're 500 and we're climbing. So as the voltage goes into the winding, it's charging up. But you can see that the resistance is high. This compressor is fine. We are well over 100 meg. All right, so we're good to go. We do another winding. Now, some of you pros might say, well, why am I checking from the contactor and not at the motor? That this is not a good test. Well, my answer to that is this is more of an effective test because I am killing 2 birds here with 1 stone. Right? So I could sit here and go to the compressor, remove all the wires from the terminals and check only the compressor. However, that might test good. That might test good and test okay. But what if my wires between my contactor and my compressor terminal have a problem, right? And the actual problem, or what's creating the short, is not my compressor winding. It is actually the wires between the contactor and the compressor terminal that's creating the short. All right, what if that's the case? Well, when I test by the contactor, not only am I testing the wires, right, the integrity of the wires between the terminals here and where it leaves the contactor over here, right? Not only am I testing the integrity of the wires, I am testing the windings in the compressor as well. So I'm killing 2 birds with 1 stone. Now the trick to this is that if when you test over here, if it comes up bad, if you get less than 100 megs, then what you're going to want to do now is come over to the compressor, remove the wires, and verify that it's not the wires, it's actually the compressor. Or may not be, it may be the wires that's the problem and the compressor is fine. All right. So, but if you measure and everything is good with the wires from the contactors, you're good to go. It's not going to, you're not going to get any difference in reading when you go to the compressor itself. So that's my thing on that. One thing I didn't do, which I should have done, is this here. So I'm in continuity meter right here. What you want to do with this test as well, you want to test the motor winding for continuity, because now this confirms that all 3 wires goes through to the compressor, right? All 3 wires goes through, and there's no broken wires and there's no open windings. So electrically this compressor is fine. It passed my Meg tester at high voltage, 1000 volts, and while using this meter, it's only 2 AA batteries, so that's only what's that, 3 volts, 6, 7, wait a minute, 3.5, yeah, 7 volts. That's it. That's all this puts out. This puts out a whopping 1000 volts. All right. So I think, guys, that's it for this video regarding compressor or motor windings Megger testing. Like I said, if your compressor windings, if the insulation is broken down and it's not completely grounded yet, it will be tripping your fuses on a hot day. It will be blowing your tripping your circuit breaker, blowing your fuses. On a hot day, you'll come in, everything is cool, you replace the fuse, you reset the circuit breaker, and then 2 days later you're back on the same call. You got to run a Meg test on that motor. Yeah, so that's pretty much it. So when you're Megger testing, what you're actually doing, you're testing the integrity or the resistance value of your compressor internal windings to the chassis ground or the casing of the compressor. And like I said, the casing of the compressor is connected to the pipe, which is connected to all the copper, to all the metal casing. It's all connected, and this is all grounded. All right. So if any of the especially when it's a 460 compressor, high voltage, these things are notorious for if you have a slight leakage to the ground, a slight leakage, it will trip. It will blow your fuse. This particular unit, I was getting a fault. I got a fault on my display here. It's kind of hard to see. Actually, it's still there. Here it is. Fault compressor 2 protection. It's kind of hard to see. This thing is, I'm doing a maintenance here. I'm going to recommend for this to be replaced. But it's flashing fault compressor 1 motor protection. I don't know if you can make it out. And this here is the motor protection. Now what that does, I have a video on that. Go and check it out. But in short, what that does is a thermistor here, and this thermistor, it goes internal to the compressor and it senses or monitors the temperatures of the winding. Now one symptom of the deteriorated internal compressor windings, the compressor is going to run hotter, right? It's going to overheat, and that's where that device picks it up and shuts it down. So in this case, given that my compressor is electrically sound, this device here is either faulty or the thermistor internal is faulty. All right, so that's it for this video. It's been 22 minutes. All right, but it was a good 22 minutes. Again, if you guys have questions, leave it in the comment section. All right, I'll gladly answer them. I'm out.